In the previous video, we looked at how to convert polar coordinates into rectangular coordinates. This time, we'll do the opposite. We'll start with rectangular and convert them to polar. This direction is a little more complicated in my opinion, but not too difficult once we get a little practice. We will again start by going back to that familiar right triangle. So let's say we have a right triangle, and let's say we have x and y, but we need r and theta. Well, if we have x and y, and we have a right triangle, then we can find r using the Pythagorean theorem. R squared is equal to x squared plus y squared. And again, if we're given x and y, the opposite and adjacent sides, we can use a little trigonometry to recall that the tangent of theta is the opposite over adjacent, or y divided by x in this case. And our goal is to find theta. So to do that, we can then take the inverse tangent of both sides. And now we have theta is equal to the inverse tangent of y divided by x. So we now have a formula for finding theta. Now we do have to be careful. Recall that the range of the arctan function is from negative pi halves to pi halves. So that is basically quadrant 1 and quadrant 4. So if our point lies in one of the other quadrants, if point is in Q2 or Q3, we'll have to do a little bit of work. Essentially, we will just add pi to theta to get the appropriate value that we need. And that'll make sense once we dive into some examples in just a moment. So let's look at a few examples. And again, we're converting from rectangular to polar this time. The first two examples may be a little wacky, but then we'll get to some more common examples. Up first, we have 3, 0. Recognize that that is on the x-axis. So it's not really in a quadrant, it's on an axis. Keep that in mind, and again, these are x, y values. Let's start by finding r. That's always the easy part. R squared is x squared plus y squared. X in this case is 3. Y is 0. So r squared is 9, and we'll take the square root of both sides, and technically we get plus or minus 3, but let's try to keep r positive if at all possible. So now again we're converting to r theta, and we have the r value. R is 3. The goal is to now find theta. Theta is the inverse tangent of y divided by x. So in this case, we have the inverse tangent of 0 divided by 3, or the inverse tangent of 0. So what angle for theta gives us a ratio of 0 for tangent? Let's go back to the unit circle and think about that. 0 radians on the unit circle would be here at the point 1, 0. So we have tangent of theta, again, is y divided by x. So in this example, this angle is actually 0. Tangent of 0 is 0 over 1, which is just 0. That means our theta in this case is 0. So we can plug that into the r theta. We now have the point 3, 0. Now be careful, that looks like the exact same point that we started with. But keep in mind, the point that we found is polar, and the point that we started with is actually in rectangular coordinates. They just happen to look the same in this case. In example B, we have the rectangular coordinate 0, 2. Again, keep in mind we're given x and y. And our goal is to find the polar version of this point. Recognize where this point is. This point is on the positive y-axis. And again, we will ultimately find our theta. Let's start again with r. It's usually the easiest. R squared is x squared plus y squared. R squared is equal to 0 squared plus 2 squared. R squared is 4. We will again take the square root of both sides, and we'll get that r is 2. Again, we'll keep the positive version. So we have an r value of 2. Let's find theta. Theta is inverse tangent of y divided by x. So inverse tangent of 2 divided by 0. Uh-oh, division by 0. We can't do that. That's kind of weird. So we get something that's undefined here. Let's think about what we can do with that. Where might the tangent function be undefined? So let's go back to the unit circle and let's think about where tangent is undefined. At the points 0, 1, we're looking at the angle pi halves. Notice that tangent is undefined. Y over x, 1 divided by 0 is undefined. Now that means down here, which is the coordinate 0, negative 1, tangent is also undefined. That's at the angle negative pi halves. So it looks like we have two angles where tangent is undefined. However, go back to the original information. Notice that the original point 0, 2 is on the positive y-axis. Only one of these points is on the positive y-axis. And that point, again, has an undefined tangent, and it occurs when the angle is pi halves. So theta, in this case, must be pi halves. In part C, let's again recognize that we are given x and y. This is in quadrant 4. Let's start by finding r squared. That is x squared plus y squared. X is 1. Y is negative 1. So we get r squared is equal to 2. We again want r, so we'll take the square root of both sides. This gives us r is the square root of 2. Again, we'll keep the positive version. So r theta is what we're trying to find. We just found r to be the square root of 2. Now, let's find theta. To do that, we again look at inverse tangent of y divided by x. That is inverse tangent of, in this case, negative 1 divided by 1. So inverse tangent of negative 1. Let's think about the unit circle now. Where is tangent -1? Tangent is -1 down here in quadrant 4. Again, going back to the unit circle, that's going to be at the coordinate square root of 2 divided by 2, comma, -√2 over 2. Think of that as the angle -π/4. So here, theta would be -π/4. Now that's perfectly acceptable unless you are given specific conditions on your theta. Sometimes we want theta to be between 0 and 2 pi. So what if we need theta to be between 0 and 2 pi? So if this is the case, we'll simply add 2 pi to our theta value that we found. In this case, we had -π/4. We want to add 2 pi to that. In other words, in this case, that would be, think of that as 8 pi/4. So that will give us the coordinate square root 2, and -π/4 plus 8 pi/4 would be 7 pi/4. It's the same exact point, but now we have certain conditions on theta, which can sometimes be a requirement. In our last example, we have, again, x, y coordinates. Our goal is to find the same thing in the polar world. Let's recognize where that is. That is in quadrant 2. Just make a note that that point, -3, 3, is in Q2. And we'll start by finding r squared. R squared is -3 squared plus 3 squared. That is 9 plus 9. R squared is 18. We'll take the square root of both sides. And again, we'll get the positive version there, square root of 18, which we can simplify. Think of that as 9 times 2, which is 3 square roots of 2. So our r, 3 root 2. Let's now find theta. Theta is the inverse tangent of y divided by x. That is the inverse tangent of 3 divided by -3, inverse tangent of -1. Again, referring back to the unit circle, like we saw last time, inverse tangent of -1, that occurs when we're looking at -π/4. That occurs at square root of 2, 2, negative square root of 2, 2. Recognize now that that point is in quadrant 4, but the point that we need is in quadrant 2. That angle is -π/4. So here theta is -π/4. But recognize that the point that we're looking for in rectangular form is actually in quadrant 2. The point we have now is in Q4. So what we want to do is we want to add pi to get us up into quadrant 2. So we're going to add pi to theta that we just found. So pi plus -π/4. That is 4 pi/4 plus -π/4. That will give us 3 pi/4. So the angle theta that we're looking for is 3 pi/4. And we now have the equivalent polar coordinate. Be very careful when you're given a certain quadrant to make sure that your equivalent polar form point is also in the correct quadrant. Sometimes there's a little bit of extra work, as we saw here, to take it from Q4 over to the correct place, and in this case, in quadrant 2.